Hello students, I am Isha Rajput, Assistant Professor at the Department of Electrical and Electronics Engineering at ABES Engineering College, Ghaziabad. So today's lecture is Classification of Energy. And contents of lecture are Introduction, Energy and its forms, Basic energy principles, difference between energy conservation and energy efficiency, efficiencies of different power plants. Introduction. Energy is one of the significant contributions for the monetary advancement of any country. On account of the emerging nations, energy area expects a basic significance considering the ever-increasing energy needs requiring tremendous ventures to meet them. Now, energy and its forms. So basically, energy can be divided in two parts. Basically, energy is of two types, potential energy and kinetic energy. So potential energy is nothing but it is a stored energy. And there are two types of energy, that is transitional and stored energy, right? So what is the potential energy? We can say system could do work but is not yet, right? System could do work but is not yet. For example, boulder at top of hill, compressed spring, coal, surface tension, gasoline, charged electrical battery, water contained in dam. For example, you can say potential energy include gravitational potential, that is elevation of a mass, mechanical form, chemical potential, for a chemical reaction to occur, electrical potential, that is nothing but voltage difference, electrical capacitance and thermal capacitance. Heat and work are examples of transitional thermal and mechanical energy respectively. Heat and work involve interactions between mass of interest known as a system and the surroundings. When considering energy, we distinguish between the system, mass of interest and surroundings with a boundary separating the two. Boundary may be physical or virtual. Now, stored energy, we can say, which has a mass, a position in a force field, etc. Basically, electrical potential, voltage, storage mechanism, you can say capacitor, inductor, superconductor, gravitational potential, you can say storage mechanism, water tower, hydraulic dam, raised weight. Inertial potential, you can say storage mechanism, flywheel, fluid inertia, mass in motion, right? That is fluid compression, flow energy, that is now kinetic energy. System, in kinetic energy, you can say system is in motion that is able to do work. For example, rotating water wheel, speeding car, baseball in flight, orbiting satellite, airplane in flight, rocket exhaust gases, boulder rolling downhill, falling leaf. That is system is in motion, that is able to do work, right? So, transitional energy in motion, energy which crosses system boundaries. For example, electrical current, work, heat, electromagnetic radiation. So, these are all examples are kinetic energy. And now these energies can be utilized in many forms. So these forms are heat, electrical, magnetic energy, sound, chemical, bomb, mass, light, electromagnetic waves, etc. Right. So these all energies can be classified into various types based on following criteria. These criteria are primary and secondary energy, commercial and non-commercial energy, renewable and non-renewable energy, right? Now, what is this primary and secondary energy? Primary and secondary energy sources are those sources that are either found or stored in nature. Common primary energy sources are coal, oil, natural gas, and biomass, such as wood, right? Other primary energy sources available include nuclear energy from radioactive substances, thermal energy stored in Earth's interior, and potential energy due to Earth's gravity. And primary energy sources are mostly converted in industrial utilities into secondary energy sources. For example, coal, oil, or gas converted into steam, Bureau of Energy Efficiency 2 and uh, electricity. Primary energy can also be used directly. Some energy sources have non-energy uses. For example, coal or natural gas can be used as a feedstock in fertilizer plants. Now, second one, commercial and non-commercial energy. So, the energy sources that are available in the market for a definite price are known as commercial energy. By far, the most important forms of commercial energy are electricity, coal, and refined petroleum products. Commercial energy forms basis of industrial, agriculture, transport, and commercial development in the modern world. Basically, in the industrialized countries, commercialized fuels are predominant source not only for economic production but also for many household tasks of general population. For example, electricity, lignite, coal, oil, natural gas, etc. And non-commercial energy, the energy sources that are not available in commercial market for a price are classified as non-commercial energy. So, non-commercial energy sources include fuels such as firewood, cattle dung, and agriculture wastes, which are traditionally gathered and not bought at a price, used especially in rural households. These are also called traditional fuels. Non-commercial energy is often ignored in energy accounting. For example, firewood, agro waste in rural areas, solar energy for waste heating, electricity generation for drying grain, fish and fruits, animal power for transport, threshing, lifting water for irrigation, crushing sugarcane, wind energy for lifting water, and electricity generation. Right? Now, renewable and non-renewable energy. So, renewable energy is energy obtained from sources that are essentially inexhaustible. For example, of renewable resources include wind power, solar power, geothermal energy, tidal power, and hydroelectric power. Most important feature of renewable energy is that it can be harnessed without release of harmful pollutants. Non-renewable energy is the conventional fossil fuels such as coal, oil, and gas, which are likely to deplete with time. Now, basic energy principles. Next is basic energy principles. There are three laws of thermodynamics. So, the first law of thermodynamics, it states that there are three laws of thermodynamics. The first law of thermodynamics, also called conservation of energy, it states that total amount of energy in the universe is constant. This means that all of energy has to end up somewhere. either in the original form or in a different form. We can use this knowledge to determine the amount of energy in a system, the amount lost as waste, heat, and efficiency of the system. The second law of thermodynamics states that the disorder in the universe always increases. After cleaning your room, it always has a tendency to become messy again. This is a result of second law. As the disorder in the universe increases, the energy is transformed into less usable forms. Thus, the efficiency of any process will always be less than 100%. Now, third law of thermodynamics. It tells us that all molecular movement stops at a temperature we call absolute zero or 0 Kelvin. Since temperature is a measure of molecular movement, there can be no temperature lower than absolute zero. At this temperature, a perfect crystal has no disorder. When we put all these three laws together, then these state that a concentrated energy supply must be used to accomplish useful work. Now, next is difference between energy conservation and energy efficiency. Energy efficiency is not synonymous with energy conservation, even though both save energy. So, energy efficiency. First is energy efficiency. Energy efficiency refers to the efforts made to reduce the energy consumption of a system such as a building, factory, or vehicle while having it perform the same functions. It is measured by the ratio of energy used to perform actual function and the total energy consumed by the system. Right? The goal is to optimize energy use by minimizing the losses. The notion of performing the same functions is important. Making a system more energy efficient means saving energy without sacrificing performance, right? Now, energy conservation. Energy conservation consists of rethinking our needs and then shaping individual behavior and collective organization to change the various ways we use energy with the goal of focusing on the most useful, curbing the most extravagant, and eliminating the most harmful. An example of energy conservation is turning the thermostat down 1 or 2 degrees in a heated room. An example of energy efficiency, on the other hand, would be to install the thermal insulation or a more efficient boiler in the building to heat the room to the same temperature using less energy. Right? So now next, these are the efficiencies of different power plants. You can see here, these are efficiencies of different power plants, you can see. And last one, these are references. Thank you.